Hello friends, today we would like to discuss about S block elements. The elements in periodic table, S block is the first group. S block group elements are also known as alkali metals, in which first group element consists of hydrogen, lithium, sodium, potassium, rubidium, francium. Francium is a radioactive element and its life period T of life period is 21 minutes only. And occurrence. Sodium is a highly occurrence order is Na, K, R. Sodium is represented by Na, potassium by K, rubidium by Rb, lithium by Li, cesium by Cs, and francium by Fr. General properties, these are known as physical properties of S block elements, that is alkali metals are, these are crystalline solids, light metallic, luster, soft, ductile, and BCC packing efficiency is 68, and void space is 32%. Outermost electronic configuration, that is general electronic configuration, is ns1, and number of unpaired electrons are 1, so these are paramagnetic in nature. These exhibits colors, good conductors, and flame test, when lithium burns it gives a crimson red color, followed by sodium golden yellow, and then potassium violet, rubidium red violet, and cesium blue. Their ionic forms are bad conductors. Okay, they attain noble gas configuration, that is diamagnetic, does not exhibit color by losing one electron. Next, atomic size. When we discuss about atomic size, these are important according to exam point of view. Atomic size is directly proportional. Atomic size is inversely proportional to metallic strength and inversely proportional to melting point and boiling point and softness. And ionization energy top to bottom decrease as the size increases. Screening effect to increase, the size increases, screening effect also increases, but IP2 value is much more greater than the IP1 value. Melting point and boiling point decreases down the group as the metallic strength also decreases. Melting point and boiling point also decreases. As we know here, melting point, boiling point, and metallic strength are directly proportional. Therefore, we can in the graphical form it can be represented in this way. First of all, lithium, sodium, potassium, rubidium, and cesium. Next, when we come to point of view of density, as the size increases top to bottom, atomic size increases, therefore density decreases, but density of potassium is less than density of sodium. This is important. Large size atom size of potassium than Ka. More number of empty orbitals, d orbitals in potassium. Next, here when we go in sodium, the d orbital is absent, that is 3d0. Okay, whereas in potassium we can have 3d0 configuration and 4s1. Oxidation state. +1 is the most stable oxidation state for 1A group elements. We have completed flame test to here. Those are lithium, crimson red, sodium, and etc. When we come to hydration energy, when M plus, that is here it can be Na plus or K plus or Rb plus or Cs plus or Li plus. When treated with n moles of water, it is the hydrostatic cation. Delta H, that is delta H negative, means always it is an exothermic reaction. He is heat of hydration, is inversely proportional to size of cation. Lithium, high hydration energy. Order of the hydration enthalpies are Li plus is greater than Na plus is greater than potassium, rubidium, cesium. This is the hydration energy order. Conductivity, molten state decreases and size increases. Less mobile electrons in cesium. Aqueous state, degree of hydration decreases and He decreases. Hydrated cations also decreases, conductivity also decreases. Okay, photoelectric effect is directly proportional to atomic size and inversely proportional to ionization potential. Cesium is best for photoelectric cell. Electrode potentials and etc. Reducing strength is inversely proportional to SRP value and directly proportional to SOP value. Lithium is a powerful reducing ability, more hydration due to more hydration enthalpy in aqueous solution. Na is lowest reducing ability due to sublimation and I. Chemical properties. Let us discuss about chemical properties. Reaction with air. When one A group element reacts with oxygen, it forms M2O oxides. This is M2O oxide, and further when it is treated with water, it forms hydroxides, and when we treat it with carbon dioxide, it forms carbon H2. And here, when we treat M2O oxides with MO2, it can form peroxides, and peroxide further oxidation, it can form superoxides too. M2O. Then lithium directly react with N2 gas. Lithium is the only one metal which it directly reacts with N2 gas. When it treated with the reaction is 6 moles of Li reacts with N2 gives rise to Li3N, and 2 moles of Li3N reacts with 3 moles of water, it gives 3 moles of Li2O and 2 moles of NH3. Okay. Next, we know oxides, peroxides, superoxides. Let us know which oxide forms oxides, peroxides, superoxides. Lithium forms only oxide but not forms peroxide and superoxides. Sodium forms both oxides and peroxides, and remaining sodium and remaining potassium, rubidium, cesium would form all oxides, peroxides and superoxides. Note this point. Stability order. Stability order in oxides. Oxide is greater than peroxide. Peroxide is greater than superoxide. Okay. Superoxides order is KO2 is this is the stability order. KO2 is less than rubidium oxide, is greater than cesium oxide. Okay. Li2O. These are the physical properties. Li2O and Na2O are colorless. K2O is a pale yellow. Rubidium Rb2 is a bright yellow. All are fluorite-like structures. Okay. Cesium C2O this is orange, and CdCl2 like structure. Okay. Reaction with water. When metal is treated with oxide, it forms the hydroxides, as we noted here. When M2 oxides is hydroxide, and this is also one more method, and delta H value is negative, delta H value negative here, it means it is highly exothermic reaction. Lithium reacts slowly with water but liberates more energy, as we here notice delta H negative means exothermic, and evaluation of heat energy would take place, and it reacts vigorously with H2O and liberates less energy, and produces basic hydroxides. Lithium hydroxide to from lithium hydroxide to cesium oxide, stability order increases, solubility order increases, that is LiOH less than NaOH less than KOH less than RbOH less than CSOH. Okay. Stability and solubility order. Next, reaction with